Hey, good evening time, everybody. Thank you for joining in on our Patreon. All right, so today I thought I would pull out an incredibly old pallet that I played with here about roughly around 7 or 8 years ago. It's been back and forth across the shelf and been thrown here and throw there and what have you. And, just kind of give you an idea how old it is. You can see the dirt still rubbing off. I haven't cleaned it up or anything. I just fixed the broken pieces and parts and decided to try and retune it. So, the retune was a success, and what kind of led me back into this, I kind of halfway tabled / scrapped the idea, and part of it had to do with the fact that it just seemed like a lot of work for no more gain in the overall aspect of things. But, the transistors are very, very cheap. And what's kind of nice is the fact that there is 3 different substitutions that I can throw in this. That's the beauty of it. The ones that are in here right now, I've got like a huge box of them. And it was one of those that's like, well, what am I going to do with these? I'd bought a few quite some time ago as far as to play with, and I kind of tabled that idea because they worked, but they weren't quite what I wanted. And then a friend of mine that does the same thing. He does, radio repairs and what have you, down at McCook's Trading Post. They're in Texas. Well, he sent me a great big box of them, because he had come across the idea several years prior to do the same thing before he and I had actually even met. So, Carl sent me up a whole bunch of parts, and, this has still got some of the old heatsink compound that I used to use, which is a copper-based, which was really good, for what it was, but at the same time, it really wasn't that great. Well, anyways, I wound up needing to replace the relay in this, and that helped out this thing tremendously. Unfortunately, this relay, not quite sure what all's going on with it, but the receive didn't work, and when I built this pallet, I built this purely out of just scraps. The transformers came out of an old amplifier. The transistors I had give to me, used piece of old heatsink that I had laying around. Everything that I could use that was used went into this on the original build. So, the only real new parts, which I did have to replace, like I said, the relay. I put a new one in there just the other day and got that taken care of, which, like I said, that way I could actually do my pass-through tune and what have you. Had I thought a few more things out a little differently at the time, I would have changed a little bit of the layout. There again, part of it had to do with building this out of the scraps that I had. So that's the reason why it's got kind of a weird configuration. The other side of that too is, I was trying to go ahead and figure out a couple different methods to where if I wanted to try to go ahead and have this board duplicated, I could go back and have it duplicated. And I think where I could actually compress this down a little bit more, had I just went ahead and made a cutout, I could have brought, the legs up and just made a couple of small crossbars across here, and then brought them back to the input transformer, and again shrunk this way as well as this way. And that may be something that I do at a later date. But the best part is, I've got the tune pretty well figured out on this. The main thing that brought me back to this was biasing. Okay, so I posted a picture here a while back about an LD Moss. Okay, well, on the LD Moss, with dealing with MOSFETs, and that's what these are, and I'll get to let you know what I used on this as well. Well, anyways, with the LD Moss, unlike the MOSFETs, or both of them, because they're still a MOSFET type amplifier, a lot of people think that they are current driven on the biasing, and the biasing that's not true. On the biasing, you really don't need any kind of real current as far as that goes, as what you need voltage. It's primarily voltage based more than current driven. So, this does have the ability for current. Let's see, little piece of something in there. So, but anyways, so I went back and I looked at the biasing circuit that I had built for this originally, and I wound up changing this one resistor. I added another capacitor here, and then this one was broke, so I had to replace this one in the circuit, just to get everything back to functioning. So I went back through and tuned the output just a little bit, and come up with a good set point here. Now these transformers here are both type 43. If I would have changed, and I think that would make a huge difference, I think I could get a little bit more out of this, and I may go back and do that and see what I get out of the transformers, or how much more I can get out of it by changing these from the type 43 and go over to like a type 61. So part of this is based off of the amplifiers that you've been seeing for the last 7 or 8 years inside of a radio. That's where the idea kind of stemmed in the back of my mind. It's like, okay, well, what can I do? Can I build this in a reasonable format that maybe I could go back and duplicate this over and over, and there again try to get everything shrunk down into a smaller platform. The answer is yes, I can get it down to a smaller platform. The output is beautiful on this. The input, it's acceptable. It's not quite as good as I had hoped, but part of that I think has to do with the layout itself. If I could go ahead and get some of this all done just a little bit differently, like for example, instead of having this small piece of coax here on the output, if I was to move this closer to the relay here and then just bring that on around, I think that would have worked out a little bit better. So, but like I said, it's just it's the layout that I chose back, like I said, 7, 8 years ago, maybe even 9. And it is what it is. So best part is, like I said, I've got it up and functioning, and that right there is 2/3 of the battle, is just getting it functioning. So, like I said, I'm pretty pleased with it for what it is. But the transistors that I've got actually in here are very, very cheap. You can buy them for like $2 a piece, but they are an IRF 530. Now the 530s, what's kind of interesting about those is that they can actually handle a higher bias voltage going into the circuit itself. And I did go ahead and put a relay, and that way I know that we don't have to worry about going into any kind of strange oscillation or anything like that. And the way the biasing circuit, and for the biasing circuit and for the MOSFETs themselves, this looks like a huge conglomeration, which, there again, it can get cleaned up and kind of a little bit more modernized, if you will. But, I've got a small voltage regulator over here, so that I can, number one, keep the voltage very, very stable. Number two, so that I can cut it down in essentially half of what we've actually got to start with. That was the main purpose of this. And then we've got our resistors here for current limiting, as well as for voltage reduction as well, to go ahead and kind of help reduce a little bit more voltage on it as well. And then, we use a traditional Xenier that goes ahead and helps keep everything stabilized across the whole feed point. So anyways, I figured I'd go ahead and show you how much drive I'm going to put in this, and then show you some numbers on there, and that it's actually a fairly clean little amplifier. So, let's kind of get some numbers here. But I thought you guys might find this interesting. So, all right. So let's look at, and we're not going to worry about pass-through because the pass-through is probably horrible on this. We'll check it out anyways here real quick. Hello, hello, hello. Audio. Yeah, a lot better than I thought. Okay. So let me turn this on and I'll show you what the input reflect is. Sorry about the camera bouncing here. Where the camera stand is mounted to the table and it's on an extended arm. That kind of is part of the reason for that. So, hello, hello, hello. Audio. So about a 0.5 watt reflect as far as that goes. So like I said, it's not bad. I'd like to see it down a little bit more for what this is, but it's not bad. Okay. So let me show you, let me turn this back off. I'm going to show you what my dead key is. So we're going to turn the 5 watt slug around. All right, so we're using a 2 watt dead key, and we're just using a Cobra 29 to drive this with. And you're going to see we've got a 250 watt slug in here, so you're going to see about 40 peak and about 11 RMS. Hello, audio, 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 audio. All right, so that's where we're going to start at. So 2 watts in, and where I currently have the biasing set at, it's going to bring it up to 25 watt carrier. Hello, audio. Hello, audio, audio. So about 140 watts peak and about 50 bird. Audio, audio. Now the nice thing is let's grab the dead key on the radio. Back that down. Let's see here. So dead key in what? It's always easier just to look because I think that's below 5 watts or right at about 5 watts. We're dead key about 2. Let's bring that carrier up to about 5. Put the amplifier on. Okay. So, all right, so 5 watts. Hello, audio, 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 audio. So we're going to be able to actually turn that way down and get the extreme low and still get about 50 bird. So, not too shabby. All right, let's take a look at the oscilloscope here that we can kind of see. Can't whistle quite. I used to be able to hit about an 850 kilohertz tone with a whistle, but hello, radio check, 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 audio check, 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 5, 5, 5, 5, 5, worldwide, worldwide, worldwide audio. So still real clean on the scope overall. Just playing around, like I said, with the 4 little Mosfets, like I said, but yeah, I think I'm going to come back to this and do this one more time and see if I can't get this, kind of scrunched down and maybe make this a little circuit that I can actually stick in there. Now, the nice thing is this only draws about 10 amps. So, it's not going to be something that's going to be massive as far as on being able to pull a lot of current. But there again, you can also go ahead and use this for multiple different things. Granted, we can also put do a 1 pill and do essentially the same, but at the same time, these transistors are so cheap, we could actually stack a lot of these into a small amplifier, and You know, if you pop any transistors, pull them out, you know, throw some new ones in there at, you know, what, if you have 20 of them in there, you could repill it for, you know, $40 or something like that, or 50, depending on what all you purchase. So that's really what it all boils down to, is it's just the economics of it. But, you know, I may go ahead, at some point and, you know, build something extraordinarily stupidly large with these and go from there. But I know I'll build another test one before I do something like that. Like I said, I'll go ahead and I'll change these out, if nothing else, and see what it does with the Type 61, because I think what it amounts to, especially on the input, if I take that down to 61, I can probably reduce the rest of the reflect. And from the most part, the way I have seen with this chassis, the way it's working, is it needs very, very little input and output capacitance for this to be happy. Almost everything is done primarily by inductance. You know, we've got only a few hundred picofarad on the output transformer. Again, that'll probably be perfect if I switch this over to a 61. But like I said, this was built solely out of scrap pieces and parts. Even the even the board that I've got here was a random piece that had give to me from another project that I did for a customer. So, like I said, you know, overall, like I said, really, really pleased with it for what it is. But you know, I think what I'm going to try to do is miniaturize this down to like 2 transistors and see what that does. You know, I've seen other types of transformers now that I can buy that are more miniaturized on both sides, and that may also go ahead and give us a little bit more of what we're looking for too, to try to go ahead and get a more common, variety or denotation. Because if I can narrow this down and maybe just use 2 transistors and get, 75 or 80 watts out of it, you know, that would make it a lot more practical too, as far as to be able to put, a little bitty slip module inside of a radio. So that's kind of what I was after, is to make something that isn't going to really produce a whole lot of heat, but that we can go ahead and slip into a radio. So, but I wanted to try it with 4 transistors, like I've seen in several different amps that I've had to repair over the years. So that's what I kind of based it off of. You know, they were able to stack 2 on each side and make everything. So, and what's nice is they'll actually take quite a bit of drive as far as input drive. You know, we've got 11 watts RMS going into the 4 transistors. You know, we may get quite a bit out of just a pair of them. So I know a pair of them, for example, in the, the Lincoln Plus 2 that I just did here recently, you know, you're seeing about 60 watts. We may get a little more than that out of a pair of them in a circuit, since we're going to be driving it with a different type of format. So, you know, we'll come back to that. As far as with the biasing, I've got a similar circuit here that I've got built, and I'll do another video on it as well for the LD MOS, because the LD MOS is going to be a little different. But, you know, like I said, this one here, it only needs the voltage. It doesn't really need any current. But speaking of current or voltage, what's kind of nice about this is we can play with the biasing. And let me show you here. All I'm going to do is just be adjusting the bias here on this. So, you know, right there is, 20 watt carrier. Hello, audio, audio, audio. So about 52 watts. Now let's turn that back off. Let's see where we're at here on that dead key, because remember I turned it way down low. Okay, so that's a watt and a half carrier. So let's turn that back up to about 2 watts. So 2 watts in with the biasing all the way up. Keep forgetting about that. So, there's about 28 watts dead key. Hello, audio. Hello, audio. So almost 60. Let's turn this up a little bit more. Turn it up where we got a 30 watt carrier with the dead key on the radio. Hello, audio, audio. All right. So, yeah, a little over 50. Hello, audio. About 55. And we don't care if we blow it up, so set it all the way up to about 40 watt carrier. Audio, 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 audio. So, not going to gain much. Now let's just play, and I'll turn this down to about where I had it on the variable on the bias here. That's pretty close. Audio, audio. So, see, even turn the biasing up and down, you're not going to really gain any extra. Audio, audio. And the only thing you're actually going to gain would be a carrier. So, let's turn that down to about 15 watts. Audio, audio. So, yeah, like I said, you're just going to start losing just a little bit. Like I said, I'll have to go back and take some measurements and readjust the voltage accordingly. But like I said, just a little, just a little circuit we've been playing with. Like I said, been pretty pleased with it for what it is. Like I said, about 40 watts PEP, or excuse me, yeah, about 40 watts PEP going in, and almost 150 on the output. So, like I said, it's a win. Like I said, I just wanted to try to build something that was a little more economical. Like I said, I started this 7 or 8 years ago, just playing around with it. So I kind of etched out everything to where I could replace the diode or the transistor on the keying circuit if something was to happen there. Like I said, to go ahead and make sure that we kill the biasing as well. And that's the big thing there is where the bias now is killed. We don't have to worry about any kind of runaway or anything insane like that. And that's what the other relay's for. But, all right, guys, hopefully somebody found that kind of interesting. Like I said, there are some things that are going to be just Patreon only. This happens to be one of those. Anytime I've got things that I'm experimenting with or what have you, that'll definitely be on Patreon only. And some things will get eventually released over to YouTube. But, maybe this gives somebody some other ideas. Like I said, eventually I'll go ahead and I'll try to build something a little bit bigger, but I'm going to play with this circuit a little bit more, changing out the transformers and seeing if I can gain just a little bit more out of this. And then I'll build a smaller version with just the 2 transistors. What's nice about that is all I'll have to do whenever I go to do that for test purposes is actually just lift the legs on these outer 2, and then I'll probably have to readjust the biasing accordingly. But otherwise, like I said, I'll see whether it will take the same tune with just 2 versus 4, and go from there. But all right, guys, I'm going to get out of here for just a little bit, and we'll be making some more videos. Thank you for tuning in here on Patreon, and we will catch you on the next live or on the next video.